All right, deep divers, buckle up, because today we're going to dive into a scenario that'll have you looking over your shoulder at the sky.
It's definitely a topic that gets people's attention.
That's for sure. We're
Ugh.
talking about asteroids, those chunks of space rock with the potential to wreak havoc on our planet.
And we're not just talking about any asteroid today. We're diving deep into a hypothetical scenario involving a specific asteroid, Apophis.
Ah, Apophis, the asteroid that caused quite a stir a few years back when scientists thought it might actually hit us.
It definitely kept us on our toes for a while.
So let's get right to the heart of it.
Mm.
In this deep dive, we're going to explore what could happen if an asteroid like Apophis were to collide with Earth this year.
Exactly. We'll be using the latest scientific projections and our understanding of asteroid impacts to paint a picture of what such an event might look like.
Okay, but before we unleash total planetary chaos, I got to ask, just how big are we talking here? When we say Apophis, what kind of visual should we have in mind?
Well, if you imagine the Eiffel Tower, that's roughly the size of Apophis.
Okay, so a pretty hefty chunk of space rock.
It is. But to put it into perspective, the asteroid that wiped out the dinosaurs Chicxulub, that was significantly larger.
Significant, like how much larger are we talking here?
Imagine parking a school bus next to the Eiffel Tower.
Yeah.
That's roughly the difference in scale between Apophis and Chicxulub.
Wow, okay, that puts things into perspective.
But here's the thing. The size of an asteroid is just one piece of the puzzle. We also have to consider its composition speed and angle of impact.
So it's not just about how big it is, but also what it's made of, how fast it's going, and how it hits us.
Precisely. Even a smaller asteroid can cause significant damage if it hits a populated area, while a larger one might just burn up on entry if the angle's right. It's all about the physics.
So how do scientists even begin to assess the danger level of these near-Earth objects?
That's where the Torino scale comes in. It's a system scientists use to categorize the potential hazard of an asteroid impact.
And where does our friend Apophis rank on that scale?
Well, initially, when Apophis was first discovered, it caused quite a stir because early calculations suggested a small but significant chance of impact in 2029. It even reached a level 4 on the Torino scale, which is the highest rating any asteroid has ever achieved.
Level 4 out of 10. That sounds pretty alarming.
It definitely got everyone's attention. But thankfully, as we gathered more data and refined our calculations, we were able to downgrade the risk. Apophis is now considered a level 0 on the Torino scale, meaning the threat of impact is effectively non-existent, at least for the foreseeable future.
Okay, so we can all breathe a sigh of relief for now. But that initial scare really highlights the importance of tracking these asteroids and having a plan in place just in case.
Absolutely. We never know when we might find ourselves facing a real-life asteroid threat, and that's what makes this deep dive so important. It allows us to explore the what-ifs and consider how we might respond if such a scenario were to unfold.
Right. It's like a planetary fire drill of sorts. But instead of worrying about a fire, we're bracing ourselves for a potential asteroid impact.
Exactly. And just like a fire drill, the more prepared we are, the better our chances of survival should the unthinkable ever occur.
So let's dive into those what-ifs. If those calculations had been off, and Apophis was indeed on a collision course with Earth, what happens next?
Well, that's where things get really interesting. We've got options, but none of them are exactly a walk in the park.
Hit me with it. What's on the table when it comes to planetary defense?
Well, one option that gets tossed around a lot is the good old-fashioned nuke 'em.
Like something straight out of Armageddon.
Exactly. While it might seem like the most straightforward solution in reality, it's far more complicated and potentially dangerous than Hollywood makes it seem. Well, for starters, there's the whole issue of what happens when you blow up an asteroid in space. You risk creating a bunch of smaller but still dangerous fragments that could rain down on Earth like a shotgun blast.
So instead of one big problem, you've got a whole swarm of smaller problems.
Precisely. Plus, there's the whole issue of radioactive fallout, which is something we definitely don't want to introduce into Earth's atmosphere.
Okay, so nuking it is probably not our best bet.
Huh?
What else is there?
Well, there's the kinetic impactor, which is basically a fancy way of saying we ram a spacecraft into the asteroid and try to nudge it off course.
So a cosmic game of billiards.
You could say that.
Yeah.
Instead of pool cues and billiard balls, we're talking about unmanned spacecraft and celestial bodies millions of miles away.
Sounds like a long shot.
It definitely requires incredibly precise calculations and advanced technology, but it's a concept that's being actively explored by space agencies around the world.
So we've got the nuclear option, the kinetic impactor. What other tricks do we have up our sleeve in this hypothetical planetary defense arsenal?
Another intriguing possibility is the gravity tractor.
Gravity tractor. What, is this some kind of cosmic tow truck?
In a way, yes. The idea is to use a spacecraft's own gravity to gently tug the asteroid off course over a long period of time.
So instead of blowing it up or ramming into it, we're talking about a more subtle approach.
Exactly. The gravity tractor would slowly nudge the asteroid onto a slightly different trajectory over many years or even decades.
Sounds like a long game.
It is. But the beauty of the gravity tractor is that it's a very controlled and predictable method. And unlike the nuclear option, it doesn't involve any explosions or radioactive fallout.
Okay, so we've got the kinetic impact of the gravity tractor, and I'm guessing there's even wilder stuff out there too.
Well, there's laser ablation, which sounds like something straight out of science fiction, but it's a real concept that's being explored.
Well, lasers. Okay, now you're speaking my language. How does that work?
The idea is to use high-powered lasers to vaporize parts of the asteroid's surface. This wouldn't destroy the asteroid outright, but it could potentially alter its trajectory enough to steer it clear of Earth.
So we're talking about using lasers to give an asteroid a very precise and very high-stakes haircut.
Exactly. And just like with the kinetic impactor, timing is everything. The earlier we detect a potential threat, the more time we have to deploy these deflection strategies and hopefully avert disaster.
So early detection is key in this cosmic game of asteroid versus Earth.
Absolutely. The sooner we know about a potential threat, the more options we have, and the higher our chances of success.
That's like they say forewarned is forearmed, but in this case it's more like asteroid warned is asteroid disarmed.
Exactly. We can't deflect a threat we don't know about. That's why space agencies around the world are constantly scanning the skies, searching for any potential hazards lurking in the depths of space.
So we've got our eyes on the skies, our hypothetical planetary defense systems at the ready. But let's say for the sake of this deep dive that we're unable to deflect Apophis and it's on a collision course with Earth. What happens next?
Well, that's where things get really interesting. And by interesting, I mean potentially catastrophic.
I'm all ears. Lay it on me. What are we looking at here?
Our research suggests two main scenarios, an ocean impact or a land impact. And both come with their own set of devastating consequences.
Okay, so let's start with the ocean impact. What happens if Apophis decides to take a dip in the Pacific?
Let's just say it wouldn't be a gentle splash. The immediate impact would be catastrophic. We're talking about an energy release equivalent to thousands of nuclear bombs detonating simultaneously.
Thousands.
That's not good. Not good at all. The shockwave from the impact would be felt around the globe, triggering earthquakes and volcanic eruptions far from the impact site.
So it's not just about the impact itself, but also the ripple effects that would follow.
Exactly. And then there's the issue of tsunamis.
Right, because if a massive asteroid plunges into the ocean, it's going to displace a lot of water.
A lot of water.
Yeah.
We're talking about mega tsunamis hundreds of feet high, radiating out from the impact zone at speeds of up to 500 miles per hour.
500 miles per hour. That's faster than a jet plane.
It gives you a sense of the raw power involved. These tsunamis would inundate coastal areas thousands of miles away, causing widespread destruction and loss of life.
Okay, I'm officially adding asteroid tsunami to my list of nightmares. But it's not just the waves, right? What about the long-term environmental consequences of an ocean impact?
You're right, the devastation wouldn't stop there. The impact would eject billions of tons of water vapor along with dust and debris high into the atmosphere. This would have a significant and potentially long-lasting impact on our planet's climate.
So we're talking about more than just a few rainy days.
Oh, much more. The dust and debris would block sunlight, leading to a cooling effect that could last for months, even years. Crops would fail, temperatures would plummet, and ecosystems around the world would be thrown into chaos.
It sounds like a recipe for a global famine. And that's just the ocean impact scenario. What about if Apophis decided to make landfall? What kind of devastation are we talking about then? So we've covered the ocean impact scenario, and it's not pretty. But what happens if Apophis decides to skip the swim and go straight for land?
Well, if a giant asteroid crashing into the ocean is bad, a land impact is even worse. We're talking about an impact crater potentially miles wide and thousands of feet deep.
Okay, so long for whatever city happens to be in the wrong place at the wrong time.
Pretty much. Imagine a crater so large it could swallow up the entire city of Manhattan. That's the kind of devastation we're talking about.
Wow, that's a visual I could have gone without. But I guess it gets the point across.
The force of the impact would unleash a shockwave that would level everything for miles in every direction. Wildfires would rage across continents, triggered by the intense heat. And if that wasn't enough, the seismic activity would trigger earthquakes and volcanic eruptions all over the planet.
Okay, so we've got fire, earthquakes, volcanoes. It's like Mother Nature throwing everything she's got at us.
essentially.
Yeah.
And just like with the ocean impact scenario, we'd also have to contend with a massive dust cloud blocking out the sun.
Right, because all that debris from the impact isn't just going to disappear.
Exactly. This dust cloud would have a similar cooling effect on the planet, disrupting agriculture and ecosystems worldwide.
So whether Apophis lands in the ocean or on land, it's a recipe for a global catastrophe.
Pretty much. The long-term habitability of our planet would be in serious jeopardy.
It's a sobering thought. But let's say for the sake of argument that some pockets of humanity do manage to survive this asteroid impact. What happens next? Do we start over, rebuild?
That's the question, isn't it? Imagine a world where the familiar structures of civilization have crumbled. Resources are scarce, communication systems are down, and we're back to basics: food, water, shelter.
Talk about a reality check.
It would be the ultimate test of human resilience and ingenuity.
So what would it take to survive in this post-impact world?
Those who survived would need to be resourceful, adaptable, and above all, cooperative. We'd have to let go of old rivalries and prejudices and work together as a species if we wanted to have any hope of rebuilding.
So it's not just about our physical survival, but also our social and psychological adaptation.
Exactly. Trauma bonding is a powerful thing, and in the face of such immense loss and destruction, it's likely that new social structures and new ways of life would emerge.
It's both terrifying and strangely hopeful at the same time. Like, no matter what life throws at us, there's always this potential for renewal, for adaptation, for finding new ways to thrive.
I think that's a very profound observation, and it speaks to the enduring nature of life itself. Even in the face of unimaginable challenges, there's this innate drive to persist, to adapt, to overcome.
And who knows, maybe this post-impact world would be a chance for humanity to learn from its mistakes, to create a more equitable and sustainable future.
It's certainly a possibility, but whether we rise from the ashes or succumb to the challenges, this hypothetical scenario forces us to confront some uncomfortable truths about our own mortality and the fragility of our existence.
It's a heavy but necessary conversation. And on that note, I think it's time to shift gears a bit and explore a different but equally fascinating aspect of this asteroid conversation.
I'm intrigued. Lead the way.
So we've covered the ocean impact scenario, and it's not pretty, but what happens if Apophis decides to skip the swim and go straight for land?
Well, if a giant asteroid crashing into the ocean is bad, a land impact is even worse. We're talking about an impact crater potentially miles wide and thousands of feet deep.
Okay, so long to whatever city happens to be in the wrong place at the wrong time.
Pretty much. Imagine a crater so large it could swallow up the entire city of Manhattan. That's the kind of devastation we're talking about.
Wow, that's a visual I could have gone without.
Yeah.
But I guess it gets the point across. So we've got this massive crater, but what about the long-term effects? Would it be similar to the ocean impact scenario with the dust cloud and climate change?
The long-term effects would be just as severe, if not more so. The initial impact would unleash a shock wave. Wildfires would rage across continents, and earthquakes and volcanic eruptions would be triggered globally. And yes, you're right, the dust cloud would be a major concern.
It's like something out of a disaster movie, but on a planetary scale.
Yeah.
So we've got all this dust and debris blocking out the sun, temperatures plummeting. What would that mean for life on Earth? Could anything survive an event like this?
That's the question, isn't it? The long-term habitability of our planet would depend on the severity of the impact and the extent of the environmental changes. It's plausible that some species, especially those in extreme environments, might find a way to survive, but it would be a very different world.
A world forever changed by one catastrophic event. It's a sobering thought.
Yeah.
But let's say for the sake of argument that some pockets of humanity do manage to survive this asteroid impact. What happens next? Do we start over? Rebuild?
That's where things get really interesting. Imagine a world where the familiar structures of civilization have crumbled. Resources are scarce, communication systems are down, and we're back to basics: food, water, shelter.
Talk about a reality check.
Yeah.
It would be like hitting the reset button on humanity.
In a way, it would be. It would force us to confront some fundamental questions about what it means to be human, about our place in the universe, and about the values we want to guide us as we rebuild.
And so it's not just about our physical survival, but also about our values and our vision for the future.
Exactly. Do we try to recreate the world that was lost? Or do we seize this opportunity to build something new, something better?
It's a lot to consider,
Mm.
but I think it speaks to the resilience of the human spirit.
Mm.
Even in the face of unimaginable loss and destruction, we have this capacity for hope, for innovation, for creating a better tomorrow.
I completely agree. And I think that's what makes this hypothetical scenario so fascinating. It's not just about asteroids and impact craters. It's about us, about humanity, and our place in the cosmos.
Well said. On that note, dear deep divers, I think we've covered a lot of ground in this episode. We've explored the science of asteroids, the potential threats they pose, and the hypothetical scenarios that could unfold if one were to collide with Earth. It's been a wild ride, to say the least.
It certainly has. But I think it's important to remember that knowledge is power. The more we understand about asteroids and the risks they present, the better equipped we are to develop strategies to mitigate those risks and hopefully prevent a catastrophic event from happening in the first place.
Absolutely. We've talked about some pretty intense scenarios today, but it's not about living in fear. It's about being aware, being prepared, and most importantly, being inspired to learn more about the universe we inhabit.
I couldn't have said it better myself. Curiosity is the engine of discovery, and the more we explore the cosmos, the more we learn about ourselves and our place in the grand scheme of things.
Well said. So until next time,
Yeah.
deep divers keep looking up, keep asking questions, and keep exploring the wonders of the universe.